Alright, in this video I'm going to talk about indeterminate forms when we're taking limits. So in the previous video we talked about how to take limits algebraically by doing direct substitution. And let's see what happens when we try that with a problem like this one. It says the limit as x approaches 2 of x squared minus 4 over x minus 2. So if I try to do direct substitution here, I have this, which gives me 0 over 0, which is what we call an indeterminate form. So this doesn't mean that our limit does not exist. It definitely doesn't mean that our limit is equal to 0, which is a common misconception from students. What it means is that we need to try something else so that we can do direct substitution. And what we're going to try in this case is we're going to try factoring to see if we can cancel out a common factor and then continue doing direct substitution. So I'm going to take this limit and I'm going to rewrite my function by factoring the top, and it's a difference of squares, so I'll end up with x minus 2, x plus 2 when I factor that. And I've got my x minus 2 on the bottom, and we see that we have a common factor here of x minus 2 that we can cancel out, and so we have the limit as x approaches 2 of just x plus 2 left behind. And now we can do direct substitution and plug in 2, and we get 2 plus 2 equals 4. So the limit as x approaches 2 of this function would be 4. So anytime you get an indeterminate form, one of the first things that you can try is factoring to see if that helps cancel out a common factor, and then continue with direct substitution. Let's look at another case. The limit as x approaches 4 of root x minus 2 over x minus 4. Let's see if direct substitution works. Root 4 minus 2 over 4 minus 4. Just like the last time, we're going to end up with 0 on the top and 0 on the bottom. So we have another indeterminate form, and we can't use direct substitution right now. So let's think about what we could do. Well, we just learned that we could try factoring, but it doesn't look like I can factor root x minus 2 or x minus 4. So another backup plan that we can have is to do what's called rationalize the numerator or denominator. And in this case, we're going to be rationalizing the numerator because that's where I see this square root expression. So what we're going to do to rationalize is we're going to multiply times the conjugate. So instead of root x plus 2, we're going to change it to root x minus 2, we're going to change it to root x plus 2. But if I multiply times that on the top, I've also got to multiply times that on the bottom to keep this function the same. And let's see what happens. I've got the limit as x approaches 4. On the top, because I'm multiplying opposites right here, what happens when I multiply those together is pretty cool. We end up with root x times root x, which is root x squared, or just x, a minus 2 root x, and a plus 2 root x, which are going to cancel each other out when we add these together, and negative 2 times 2 is negative 4. So we end up with just kind of a difference of squares here, x minus 4. And on the bottom, I'm going to leave these as my factors because my goal is, again, to cancel a common factor. And I see that on the top and the bottom now I have x minus 4. So I can go ahead and cancel that common factor. And I have the limit as x approaches 4 of just root x plus 2 is left behind, but it's on the bottom. So 1 over root x plus 2. And now I should be able to go ahead and do direct substitution. So I'm going to say 1 over root 4 plus 2. Or 1 over 2 plus 2, which is equal to 1/4. Oops. So this limit would give me 1/4. So think through when you have indeterminate forms. Can I factor? If not, can I rationalize? And then if none of those things work, remember we've always still got our option to graph the function and look at the left and right approach if none of these strategies work.